Hello everyone, my name is Nived P. and I'm one of the co-authors of the paper Detection of Fraudulent Credit Card Transactions in Real Time using SparkML and Kafka, and I'll be presenting our work through this video. These are some of the contents that I'll be going through in this presentation. With rapid expansion and development of e-commerce, the use of credit cards for online shopping and purchases have increased rapidly. Along with this, there has also been a huge rise in the number of fraudulent transactions, and credit card fraud has become a major menace. Many new technologies such as artificial intelligence, machine learning, and data mining, and new and innovative ways of detecting fraudulent transactions have been evolved. In our work, we make use of such latest technologies and implement a working solution that can be deployed for real-world usage. Our work primarily addresses the problem of classifying a credit card transaction as fraudulent or legitimate. For doing this, we have utilized SparkML and Scikit libraries for training machine learning models. The dataset used for model training are also cleaned and pre-processed using a number of different Spark packages. The trained models are also deployed on real-time streams of data generated using Kafka streaming technology. Firstly, finally we created a user interface for visualizing the predictions made by our trained model in real time. For model training, we have used a publicly available dataset consisting of transactions made by European cardholders. The raw details of transactions are kept hidden and they are represented by a number of features obtained using PCA on the original data. The original dataset is also highly unbalanced, with less than 1% representing fraudulent transactions. To overcome this issue, firstly we have used a synthetic minority oversampling technique, which is a statistical technique for increasing the number of cases in a dataset in a balanced way. Here we use this technique to randomly duplicate examples in the minority class, thereby increasing their overall frequency. Another method is undersampling, which is used for randomly deleting examples in the majority class and is basically the opposite of oversampling. The balanced dataset obtained using undersampling is shown here. Coming to methodology, we have followed 4 steps. In the first one, we load and pre-process our dataset. This is done using various modules present in the Spark SQL library. In the next step, we perform model training. We have trained multiple models including naive Bayes, random forest, KNN and SVM for performing classification, and we have evaluated their performances. The model implementations and training were performed by making use of SparkML and scikit-learn libraries. In step 3, we generate real-time data streams. Here we have used Kafka distribution to mock data streams in our local machines. It makes use of a Kafka producer that eats data from a CSV file and outputs a real-time streams of data including timestamps, similar to a real-time data. Coming to data preprocessing, we have used SparkML library for creating a data frame that can be properly utilized by the machine learning models. Firstly, we convert the data frame either into an RDD or a Spark data frame. The Spark data frame provides an RDD attribute to return an RDD. We initially have a pandas data frame that is generated from the given CSV file, and it is then converted into a Spark data frame first for modeling purposes. In order to perform detections on for fraudulent credit card transactions, that we have trained 10 different machine learning models for estimating the final predictions. Each model provided a different accuracy in different scenarios. Hence, in our real-time implementation, we have done a statistical analysis after getting the predictions from each model and have taken the predictions which is more statistically relevant. These are the different steps. involved within a generation of real-time streams of data using Kafka. First, we will create a Kafka producer that reads from a .csv file and then turns the data into a real-time Kafka stream. The producer will create a Kafka topic which will contain the messages generated by the producer. The producer also publishes the message to a host address using socket. Next, we will use a Kafka consumer which uses machine learning models to predict Kafka streams. The figure shows the streams of data generated by the Kafka producer, which is then subsequently received by the consumer for making the predictions. This slide shows a summary of our entire architecture, in which first we take in the raw data, then convert it into a streams of data using Kafka. Then we perform model predictions on these streams of data, and the results is finally displayed on a user interface built using Streamlit. Here are some of the results we obtained comparing the performances of all the different machine learning models we have trained. The table in this slide shows the number of wrong predictions made by each of the models on the validation set of data. And from these results, we can see that the models such as random forest and polynomial SVM performs much better compared to other models. Here we can see the model predictions on real-time data generated by the Kafka producer, and on the right we have the Streamlit app that shows that is used for visualizing the predictions in a real-time way. The pie chart is also plotted on the interface for visualizing the results. To conclude, in our work, we have successfully created a real-time credit card fraud detection system using Apache Spark, Kafka, and machine learning algorithms. We have used Spark SQL for data processing and balancing out the unbalanced data, which was used for machine learning. SparkML and scikit-learn libraries were also used to implement and train the 10 different machine learning models used for making the predictions. The trained models were stored as a pickle files in order to be used for real-time predictions. The Kafka producer was created to generate mock real-time data from a CSV file and publish the data into a local host. We have also created a Streamlit application that acts as a Kafka consumer and retrieves the real-time data to produce prediction results from the trained machine learning models. The Streamlit application provides an interactive web interface to visualize and analyze the prediction results in a seamless and interactive way. Our interactive web interface would analyze the count of the fraudulent credit card transactions and provide us a graphical visualization for the same. The designed fraudulent credit card detection system can have varied applications in reinforcing security in online banking, purchases, transactions, and many more. Thank you.